So, welcome back to part 2 of Secrets of the Periodic Table, and I like to call part 2 the Two Towers, after Lord of the Rings. Because when you go to look at this periodic table, the way this is organized, if you look at just the shape of it, you can kind of see there's this tower over here on the left that takes up these two columns, and there's this big kind of skyscraper tower a little bit lower on the right that takes up these 6 columns. Oh, and the 6th column is just one head taller than all the rest of them. So here's these two towers on either side of this periodic table. So I want you to keep these two towers in mind because these are going to come into an important play here in a second. And of course, this is all named after everybody's favorite movie, Lord of the Rings, The Two Towers. So here's a tower over here, and that's the good tower. And then this is the bad guy tower with the Eye of Sauron. Ah, don't look, it's the Eye of Sauron right here. Okay, so two towers, right? So when you look at the periodic table, you're going to see these two little skyscrapers on either side. And so here's a skyscraper, and that takes up 2 columns. Oh, and by the way, a row goes this way. It's also called a period. I don't know why they call it a period. It seems kind of old-fashioned to me, but that's why they call it the periodic table, because each of these rows are considered periods. So these are the rows, and the columns are, if you think to, those old mansions, and they have that big front door, they have the big steps leading up, and they have that big front door, and then around the big front door there's these columns that go up and down as part of the architecture, kind of like the White House. So columns go up and down. So that's how I remember which is rows and which is columns. Columns are the ones going down. So this would be a column, this would be a column, this would be a column, and so forth. And going across, these are rows. Row 1, row 2, or periods, same thing. Period 3, period 4. Anyway, you get the idea. So when you're looking at the periodic table, look at these two towers, or these two skyscrapers, one on each end of the structure. Here's a skyscraper over here, and that takes up 2 columns, column 1 and column 2. And then if we go all the way over to the right side of this structure of the table, we can see that there's a tiny bit shorter, but also tower-like skyscraper over here. So this would be column 3, column 4, column 5, column 6, column 7, and column 8. And so we're going to number these 2 towers in congruous numbers with the 1, 2, 3, 4, 5, 6, 7, 8 columns, because these two towers are both part of what we call Group A. Group A are the 2 towers. If you get lost, you can even take a look up at the top of each column, and it'll say what group it is. You'll see that says 2A, and over here 3A, 4A, 5A. So the A's give you the clue. This is in Group A, okay? Does that make sense so far? All right, now, between these 2 towers is a bridge. So this is how I look at it. I look at it like between these 2 towers, there's a bridge that connects these 2 towers. Here's the bridge connecting these 2 towers. All right? So this bridge is going to be Group B, is this bridge that connects the 2 towers. As well as these 2 rows beneath it are also technically part of Group B, but we'll get to that a lot later. You're really not going to have to worry too much about this block down here in your first year of chemistry. That doesn't come until way, 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 way later. So don't sweat the small stuff. Just make sure you're grasping these main points that I'm giving you. Like the 2 towers is Group A, and the bridge is Group B. B for bridge, okay? Okay, so now that we have that established, we have the 2 towers and the bridge. What we need to be looking at is Group A. You're going to do most of your stuff with Group A. The Group B is going to get in. You're going to get into Group B just a little teeny tiny bit in this first year of chemistry. But what you really need to be paying attention to is Group A, the 2 towers. Okay. Now with the 2 towers, the tower on the left that takes up only 2 columns. These are all metals, with one exception, but we'll get to that in a second. But these are metals, and then the bridge that bridges the 2 towers together are also metals, but these are called transition metals. So you can think of that these are the metals that make the transition from one tower to the second tower. Okay, so transition metals. And as I said, you're going to dive just a teeny tiny bit into the transition metals, but what you really need to worry about is the stuff in the elements in Group A, the green that I've shaded green for you. Now, we have the metals on the left, and then a bridge called the transition metals, because they're still metals, but they're making the transition over to the tower on the right, are the non-metals. So elements are pretty much either metals or nonmetals. It's one or the other. So over here in the nonmetals, it's mostly gases. Now there's carbon. Carbon's not a gas. Carbon's carbon. But then right next to it, nitrogen. Nitrogen's a gas. Oxygen is a gas. Chlorine is a gas. So most of these nonmetals can have a gas form, or a lot of them at least, but they're all nonmetals. So remember, metals are on the first tower. Transition metals is that bridge. They're building a bridge to get to the second tower over here, which are all nonmetals. But there is an element that will not follow the rules. If you have any experience with the periodic table, you might have noticed something, and that is hydrogen. Hydrogen is at the top of Group 1A. hydrogen is the very first element, so it's number one. It's in place number one. But that's in the metals section, isn't it? It is, because the metals section are those two first columns, right? At the periodic table, hydrogen is not a metal. Hydrogen is a gas, right? And then you put hydrogen and oxygen together and you get water. But hydrogen sometimes doesn't really behave like a metal. So what you do when this pops up is just ignore it and don't sweat it, because you're just going to get used to it. You're just going to get used to hydrogen popping around, doing different things, following different rules in different cases, and you'll just get used to it. It's really not as confusing as it may sound at first. So what you want to do is, see, here's hydrogen over here, the very first element right here on the left in group 1A. So a lot of times, hydrogen actually acts like it belongs over here next to helium. It acts like a gas. So it should actually belong over here. It's still number one. The atomic number is still number one. The street address is still number one. But the whole house is just kind of scooched over next to helium over here in the second tower of group A. So a lot of times it'll behave like a gas. It just pops back and forth, and it really doesn't stick to one set of rules or the other. So besides hydrogen, all the rest of them behave like they should. They behave right. So we have the metals over here and the non-metals over here. And we're just going to not worry about the bridge anymore. We're just going to be talking about group A for right now, because that's most important for you to learn. So we have metals, non-metals. What does that mean? How is that going to affect these elements if they're metals or non-metals? So metals, over here on the left. So let's say, for example, we have an element, a metal element, and it's got 4 protons in it. There's 4, and protons are positive, remember? And then there's the neutrons that it's with. And then the very first orbit around the nucleus has these 2 electrons in it. And how many electrons total is this element going to have? 4, right? Because however many protons is in the nucleus, which is 4 in this case, that's how many electrons you're going to have circling around, orbiting around outside of the nucleus. So we have 2 electrons very close to the nucleus in the very first orbital, and then we have another orbital that's a little bit bigger for the rest of the electrons, for the other 2 electrons, for a total of 4. Oh, but look, there's only 1 electron on this in this orbital, and this other one kind of flew off. Whoop! Oops! Doo-doo-doo! And it flew off, and it flew away, and it went over to its friend's house. So this metal on the left has 4 protons, so that means it has to have 4 electrons, right? Because everything in chemistry happens to get back to balance. And if it's going to have 4 protons, which are positive, then you're going to need 4 electrons, which are negative, in order to equal 0. Okay, so what happens when this electron flies away, and this metal loses the electron? Well, all of a sudden, it's not balanced anymore, is it? Because metals sometimes lose an electron or 2. The electrons will be orbiting around, and boop, they'll fly off for one reason or another. And so, if you have 4 protons, which are positive, but now this only has 1, 2, 3 electrons. 3 electrons, which are negative, because it lost an electron. Well, the charge now, it's going to have a charge. It's not going to be 0 anymore. It's going to be a positive 1. And I know what you're thinking. You're like, well, how come it's a positive 1 if it lost an electron? Well, don't forget, the electrons are negative. So if it lost a negative, that's like saying you're subtracting a negative from something. Like, if you have 5 minus 3, that's going to be 2. But if you have 5 minus a negative 3, that's going to be 8. And I'm not going to get into positives and negative subtractions right now, but I'm sure there's some really good YouTube videos explaining positives and negatives, and I should probably do one myself, because I have a lot of students who get in trouble with positives and negatives, and that affects their chemistry. So make sure you know how to add and subtract positives and negatives. Chemistry math is not really all that hard. It's mostly add, subtract, multiply, and divide, and that's it. But you do have to make sure you don't get tripped up. So if you know that you usually get tripped up with positives and negatives, give yourself a refresher and double check and make sure your work is correct before you turn it in. So this metal is going to have a positive 1 charge because it lost an electron. Well, now down the street over here in these non-metals, in this non-metal element, as you can see, it has 7 protons in the nucleus. So if it has 7 protons in the nucleus, how many electrons should it have orbiting around the nucleus? Well, 7, right? Because if it has 7 positives, it needs to have 7 negatives in order to balance out to 0, right? But this little guy came over from the metal, and he was like, hey, this is my friend over here. Can I come over and play and hang out? And the non-metal's like, I guess so. Okay. And so now it has an extra electron. So now, instead of 7 positive protons and 7 negative electrons, it still has, the number of protons don't change. It still has 7 protons. The number of protons don't change because they live in the nucleus. They just stay in their house. But it has an extra electron. It has 8 electrons instead. So if it has 7 positives and 8 negatives. Now, all of that we just went over leads us to the important conversation about ions. Ions. And an ion just means that one of those elements, one of those atoms of the element we were talking about, lost or gained electrons. It could be one electron or it could be many electrons. It doesn't matter. If one of these elements that are supposed to have the same number of protons equal the same number of electrons, but an electron flew off into the atmosphere and hooked up with a different atom, then all of a sudden they're violating the rules and they're called ions. And ions are called that because they have a charge to them. So ions are when the number of protons do not equal the number of electrons orbiting around that nucleus of that atom, of the element. So as an example, let's say we had lithium, which here is the little Scrabble tile for lithium. And here is the atomic number for lithium, which is 3, which is not only the street address, but also the number of protons, and also supposed to be the number of electrons, 3. But so what happens if this lithium, one of the electrons fly off and go off to hang out with somebody else? Well, they're only going to have 2 electrons, right? Instead of the normal 3, because the third one flew off. So if they have 3 positive protons, but they only have 2 negative electrons, then they're going to have a positive 1 charge. And so that means that this lithium is an ion. So an ion is when it has a charge. Okay? Now, what if the element we're talking about is nitrogen over here, this number 7, atomic number 7, nitrogen. So if nitrogen is atomic number 7, what does that mean? That means not only is it the street address for nitrogen, but that's also how many protons it has, which is also how many electrons it's supposed to have. But over here in the nonmetal section, usually these nonmetals don't have a tendency to lose their electrons. The electrons don't just fly off. What happens is, over here in the nonmetals section, is that this is where those runaway electrons actually go from these first 2 columns in group A. So the electrons leave, they run away, run away, run away, and they go over here to the nonmetal section and they join up. So what happens is the nonmetals, they tend to gain electrons, not lose them. So before we were dealing with these first 2 columns, and if these columns have any alteration of their electrons, it's because the electrons ran away or they flew off out of orbit. But these nonmetals over here on the right, these gain electrons. They don't lose electrons, they gain electrons. So nitrogen has an atomic number of 7. You can see that in the Scrabble tile on there in the periodic table. That 7 means that the 7 is its address, right? But that also means that that's the same number of protons it has, because protons don't change. Number of protons don't change. They live in the nucleus. They don't go anywhere. They stay in their house. So there's 7 protons, and there's supposed to be 7 electrons, right? So since nitrogen is a nonmetal on the right side of the periodic table, it's the one who's going to add extra electrons to its orbits. Sort of like when you were a kid, there were those houses, there were those friends where you would always go over to their house for dinner, and there were those friends that always came over to your house for dinner. So if you have a metal, those are the friends who are always going to other people's houses for dinner. If you have a nonmetal on the right side of the periodic table, those are the houses who always have the extra kids over for dinner. So here's one, here's an extra electron, and here's an extra electron. So let's say this atom right here, and it's got a proton number of P7, 7 protons, and that's positive, so positive 7. And normally it should have how many electrons? Well, 7. It should have the same number of electrons. But let's see, 1, 2, 3, 4, 5, 6, 7 were the original electrons it had. But then it has 8, 9 electrons because 2 friends came over to have dinner with them. So now it has 9 electrons. So if it has only 7 positive protons but 9 negative electrons, that leaves it with a charge of -2. And so that would be an ion because it has a charge instead of it balancing out to be 0. And an ion can be like this, a -2, or an ion can be like our previous example when it had a positive 1 charge. An ion just means that it has a charge, that it's not 0, it has a charge. That's all an ion means. Now, an ion, there are 2 different types of ions. There are cation ions and anions. And really the definitions of these are very simple. A cation means the charge is positive. So just like here, when this has a positive 1 charge, that would be a cation. An anion, of course, would be the opposite when it has a negative charge. So just like above here, when this turned into a -2, that would be an anion. And the way a teacher told me to remember it is because cat has that T in the middle of it. It has that cross that looks like a plus sign. So the plus sign means the cation is the positive charged ion. And the anion is going to be, just by process of elimination, the negative ion. So before we go any further, let's not forget that what I'm talking about when we lose an electron or we gain an electron on an element, this is going on only in the valence shell of that element, and that's the outermost orbital. It holds 1 to 8 electrons only, and the rest of the electrons of each element are in orbitals closer to the nucleus. But the valence shell is the most outside, the outermost shell. You think of it like an eggshell. That's why they call it a valence shell, and to separate it from the rest of the orbitals. The valence shell is the most outside orbital that the element has, and that is where we lose or gain electrons. So only in this outermost shell can an electron fly off and you lose it, or can an electron from somewhere else come over and join you for dinner. Only in this valence shell, the outermost shell. The inner shells do not change their electron patterns or their electron numbers, which is great news because you don't have to worry about any of the inner orbitals of the atom. All you have to do is study the outermost, the valence shell, the outermost orbital, and what is going on with the 1 to 8 electrons there. And that's it. That's what chemistry is. Chemistry is mostly just studying what's going on with the electrons in the outermost shell of the element, of an atom of the element. And that is the focus of most chemistry subjects that you're going to get into, especially in the Basic Chemistry 101. So we went over the Group A, and I numbered the Group A's column numbers. See, there's 1 and there's 2. And these, if these look weird to you, these numbers, these are called Roman numerals. Roman, like the ancient city of Rome, Roman numerals. So if these don't look familiar to you and you don't know how to read Roman numerals, then look that up, because you're going to need to just be familiar with Roman numerals. It's not hard at all, but you're going to need to be familiar with Roman numerals in order to read a periodic table that your teacher might give you. It might be in Roman numerals, it might be in regular American numerals, it depends. But usually when we're numbering the group columns, it's numbered in Roman numerals, so we can set that apart from other numbers and other labels that are going on these columns. So the Roman numerals are the ones that that number the columns for Group A, and this is Group A. Remember the 2 towers, Group A. The tower over here on the left and the tower over here on the right is Group A. So I gave you a couple examples earlier about gaining and losing electrons potentially with an atom, but how are we supposed to know how many electrons were gained or lost for a certain atom if the atom is an ion? Because remember, an ion just means that the atom has a charge because it gained or lost an electron or electrons. I'm putting the S in parentheses because it could be just 1 electron or it could be more than 1. So how are we supposed to know how many electrons were gained or lost in a specific element? Well, it's really easy. Like if we're not told, like if, for instance, beryllium, if we have an ion of beryllium, that's going to be a 2 positive, which means that beryllium lost 2 electrons. But how are we supposed to just know that off the cuff? Are we supposed to memorize a whole bunch of stuff? No. Don't worry. You don't have to memorize anything. That's why the periodic table is so cool, because if you know how to read it, it gives you half the answers. So, for instance, here's beryllium right here. And so it is in the metals section of Group A, right? Because these are metals. And so that means that it could possibly lose electrons, or an electron. Because metals lose electrons and become positive. I'm just going to put this in a circle so we know that means positive. And the nonmetals over here, nonmetals, gain electrons and become negative. All right, so talking about beryllium over here, beryllium is a metal. So that means it must have lost 1 or more electrons from that outer valence shell that I just showed you. Well, how are we supposed to know how many electrons beryllium lost if it says the ion beryllium? Well, okay, it's an ion, so that means it's lost some electrons, but how are we supposed to know how many electrons it lost? So here is the cool secret about the periodic table, and that it gives you the answers. See this one column 1 right here for group A? This whole column right here, column 1? So whatever number column it is, that's how many electrons it loses. So if we're talking about lithium, an ion of lithium is a 1 positive because it lost 1 electron. And here's potassium. Potassium as an ion is a 1 positive charge because it lost 1 electron. This entire column number 1, the only amount of electrons these guys can lose is 1 electron. So if you're talking about an ion from an element from this column, that ion is going to have a 1 positive charge because it only lost 1 electron. Now let's go to the second column. Same with the second column. Second column, it lost 2 electrons. So that means it has a positive 2 charge. Because remember, if you lose electrons, because electrons are negative, if you lose electrons, it makes you more positive. So this beryllium, the atomic number here is 4, right? So that's the street address, and that's the number of protons in here. But it's an ion, so it lost 2 electrons. And so that makes it a positive 2 charge. And everything in this column number 2, is going to have a positive 2 charge if it's an ion form. If it's in the form where it lost electrons, it's going to automatically, you can totally just assume it lost 2 electrons, so it's got a positive 2 charge, if it's an ion. Now, over here on the right side, the nonmetals is exactly the same thing, but it's the opposite, because the nonmetals gain electrons. So we have column 3, here's 4, here's 5, here's 6, here's 7, and here is 8. Now here's the difference in reading the periodic table between the metals and the nonmetals. Okay, let's just consider 8. This is a baseline, okay? This is home plate. And so you count backwards wherever the element is from column 8. And however many columns backwards it is, that's how many electrons it gains. So, for instance, let's think about oxygen right here. So here's oxygen right here. Okay, here's oxygen. So we're going to start over here at column 8, the very rightmost column, the end column here, and we're going to count backwards and see which column, how many columns we take to get to oxygen. So 1, 2. So it took us 2 columns to go counting backwards to get to oxygen. That means oxygen gained 2 electrons if it's an ion form. An oxygen ion gained 2 electrons, which means it is a 2 negative charge. And so everything in this column that oxygen is at the top of, does that exact same amount. Anything in this column, if it's an ion form, that meant it gained 2 electrons, and it has a 2 negative charge, negative 2 charge. Now let's do another one. Let's talk about carbon. Let's take carbon, for example. Carbon is right here. See the C. C stands for carbon. So we start over at the very last row, or very last column, this column number 8, and we count back 1 column, 2 columns, 3 columns, 4 columns. So carbon is 4 columns back from column number 8. So that means carbon in ion form can gain 4 electrons. And that means it's going to have a negative 4 charge. And that's it. You just count backwards from the very last row, or the very last column. And that's how many, this entire column right here that carbon's at the top of is exactly the same thing. It's going to, if it's an ion, it's going to gain 4 electrons, exactly 4, not 3, not 5, but 4. And that's going to give it a negative 4 charge. And then back over here on the left, the metals, over here on the left, is if it's in column 1, it will lose 1 electron. If it's in column 2, it will lose 2 electrons. The whole column is exactly the same thing. Column 2, it's not going to lose 1 electron. It's not going to lose 3 electrons. It's going to lose exactly 2 electrons if it's an ion, every single time. And so that's a positive 2 charge. So just to recap real quick, the metals, which are these 2 columns right here on the left, metals, they're the left tower. You know how I was calling these the 2 towers? So here's this tower on the left. So the metals are the left tower. They lose electrons. And the number of electrons that they lose is the same number as whatever column they're in. So this is column 1, this is column 2. So depending on which column they're in, that is how many electrons they lose. So that makes it a positive ion with a charge the same number as the column that it's in. And then the nonmetals, which the nonmetals are the tower on the right,
they gain electrons, and that makes them become a negative ion. And you find out how many electrons they gain, and therefore what their negative charge is by counting backwards from column 8. So 1, 2, 3, 4. So carbon would have gained 4 electrons, and therefore is a negative 4 charge.